start recording. And I do have slides this time, so that's fun. Slides that have wonderful animations. Yeah, they're all good. All right, cool. So I'm going to assume that everybody is, if you can't see my computer, then just go ahead and log on to Zoom so that you can see that. Let me shrink all that up there as well. Yeah, cool. And so are we working here? Can I get my slides to work? Apparently not. There we go.
Nice.
Magic. Okay. Yeah, cool. All right, so today I'm going to talk to all of you in a little bit more detail about webpack. What do you understand about webpack so far? Do you know what it even does? Or is it just like this magic box? If it's a magic box, what does the magic box do?
Well, it like bundles all of your code together into like one master webpack file, webpack.js, right?
And so it is something that it can do, yes.
Yeah.
And that's fundamentally what it's about. It's like it is a module bundler. It's going to take a lot of JavaScript files that are written as modules, like they have imports and exports, and it's going to bundle them up into one or possibly more. As we're going to find, we're going to have more than one. We can have more than one bundle. Anything else that Webpack is? Anything else it can do?
It has like loaders. Like it lets you bring in Babel, I think.
Yeah, exactly. You can bring in these loaders, and what they essentially act as they act as middleware for transforming your code from one form to another. Cool. Okay, let's dive in. Cool. So here's the trajectory. We're going to talk about what Webpack is and why we use it. What does it do to your code, as well as some core concepts. That is the entry point, the output, loaders, and Webpack plugins. We're going to talk about development mode versus production mode. And we're going to see how to implement a couple advanced techniques that are used sort of like across the board, not just with Webpack, but with any kind of JavaScript bundler, like hot module replacement and code splitting. And we're going to see how that gets implemented with Webpack. Cool. So as we talk about, Webpack is a module bundler. It's going to take one or more source files and spit out one or more bundle files. Sort of like the basic usage of Webpack is to go ahead and take all of our source code files and get this one bundle. But we can also use it to make multiple different bundles. We can have we can have more than one entry point. We're going to see that this is going to become important when we start to talk about the techniques that we use for splitting our code up into multiple bundles and the advantageous reasons that we might do that for. And what it does just out of the box is it's transforming the module syntax that you have in your code into that you have sort of like in your source code into actual modular runtime code. We can also, it's very configurable. You can include various kinds of source code, not just JavaScript, but also like CSS, JSON stuff that normally isn't modular, and you can perform transformations on that and cause that code to be modular as well. And just sort of like the one thing here that I want to make sure that you don't do is confuse Webpack itself with Babel, because Babel can be used by Webpack to transform your advanced language features into things that are safe for the browser. But Babel itself is still just used as a loader by Webpack. It's just a piece of middleware that we plug into Webpack. Webpack is a thing that orchestrates everything that's going on by saying that if we were to say like Webpack is like Babel, that'd be saying like body parser is like Alt Express. That doesn't make sense. And so the reason that we use Webpack is because we want modularity primarily in our front-end JavaScript. You can use Webpack for your Node code as well. That's perfectly possible, but it's not really totally what it's about, because the reason that Webpack exists is for browser-side JavaScript because the ES 2015 module system that was introduced that eventually could make browser-side JavaScript modular in and of itself. It can make it so that if you have a script type that has a type of module, then your browser will in fact be able to execute that code in a modular way. It won't pollute the global scope. But they're still very new, and you can only do this in very latest versions of the coolest browsers. But generally, because we're web developers, something that we're very sensitive to is that we want to make sure that our code can execute on as wide a variety of browsers as possible, so that our applications can reach as wide an audience as possible. But even so, even after this happens, in this wonderful world where we finally have our module script tags, you may still choose to use a module bundler anyway, because it does allow you to transform your source code in really interesting ways, which lets you do things like use new language features early, but also modularize things that are normally not modular at all, like CSS. Because there's probably maybe in the distant future, we'll have some kind of native web standard for modular CSS. But as it were, if you want to take advantage of something cool like scoping CSS to a particular module so that those classes can't be used elsewhere, that's something that needs to be done by JavaScript. It needs to occur in this compilation phase. So that's why you would still even use Webpack. Even in the future, we'll probably be using some form of module bundler. So even though we're talking about Webpack specifically today, be aware that there are other things out there. There's Rollup and there's Parcel. I'm very excited about Parcel in particular. But really any of these concepts, I'm hoping, are more or less applicable to any kind of module bundler that you use. And they're probably not going anywhere anytime soon. Cool. So we know that Webpack now, it's taking our code and it's transforming it into something that is going to be modular when it's actually executed. And it does that by taking our source code and compiling it or transpiling it, whichever nomenclature you'd prefer to use, into some separate form that when it's executed is going to essentially simulate modularity on the front end. So let's go ahead and let's take a look and see what that does. So here you can see we have this very easy to read module system right here. So okay, it looks really scary because it's got all this garbage and shit everywhere. But it's actually so here what I have here is a very basic example. I've got a foo.js and a bar.js, and foo.js just imports bar.js, and bar.js just exports a function that says hello, something like that. And right off the bat, it's even in a non-minified, non-uglified form, it's still a lot of crap here, a lot to sort through. So what I've done is I've kind of gone through, I've removed a lot of the crap and sort of simplified some things to sort of give you the main idea of what's going on in here without having to go ahead and do that yourself. So here's what we actually have here. Here's what Webpack is actually doing. It's actually very simple. Let's say we've got, what it does is it collects all of your source code files. In this case, I've got my foo.js and my bar.js. And it's just putting them into this object that we might call, your modules. So the key value pairs here are going to be the names of your files. And what it's going to set the values to is it's going to set them to be these functions, just setting them to be functions that all use strict by default, by the way. So if you're using Webpack, you don't need to say use strict at the top of your files. They're already use strict for you. And then what this function does is it receives 3 arguments. It receives an argument called module, an argument called Webpack exports, and an argument called Webpack require. These are roughly corresponding to what you actually may be familiar with in the common JS format that Node uses. You got your module, you got your exports, and you have require. And then here's where the magic comes in. What it has here is it's got the contents of bar.js and it's got the contents of foo.js, and they're stringified and they're evaled. like this is like literally from like the latest version of Webpack. It just runs them through eval. And the magic happens, the place where sort of like the interesting compilation occurs, is that here we have the stringified contents of bar.js and foo.js. And what Webpack has done that's interesting is it has gone through your source code, it's read it as a string, and it has replaced any instance of saying like import, export, and things like that with these values on scope here: module, Webpack exports, and Webpack require. So that the actual like runtime of these functions when they're eval is going to be using these values on scope in place of kind of like the import export syntax. If we go back a bit actually to our scariness right here, we can actually sort of see like what that might look like. Is here, like we're saying like Webpack require, like Webpack export. We can see like these are places where in my source code where I've had import, export, stuff like that, it's gone through and it's replaced and it's sort of like inserted its own values into there. It's still like a little bit of a mess to read, of course, but that's sort of what it's done. That's the magic-y part. The rest of this though is actually fairly basic JavaScript. So that's what our modules are. So here's where that comes into play with essentially like Webpack's runtime. Like the way that it's taking your modules now and it's going to execute them. Here's what that looks like. Is we've got this big iffy here. Can everybody see that? Is any of my Zoom Chrome getting in the way? Okay, cool. We got this iffy. We pass in our modules, that same object that we looked at before, where the key value pairs are like the names of our files and then the functions, and we're passing them in here and we're calling that modules. So this is Bootstrap. This is what happens when our JavaScript executes on the browser. Is what we'll do is we'll set up just a cache, just a dictionary here for our installed modules, and then we will define that _Webpack require function. And it's going to take in a module's ID. That is the file name. And then what it's going to do is it's going to return the result of saying Webpack require our entry point, which in this case is foo.js. Just go ahead, we've put in the first module ID, and we kind of like kick things off. So then the way the Webpack require is implemented is it's something like this. It works the same way that we know requiring something in common.js works. We check and see like, is there installed modules of module ID? Have we run this before? If so, then we return the .exports of installed modules at module ID. If not, then we're going to create a new module and put it into our cache. So we're going to say that we're going to have a variable called module here for a moment. It's going to also be an object that's in installed modules at module ID. And it's just going to be this object here that has an exports object. So then we're going to execute that module function. Remember, this is the function that has module exports and require being passed in as an argument. So we're calling it. So it's the modules.exports, that is this object right here. That's going to be our this context. And we're invoking it with module exports and require, just like we saw previously. So we're just going ahead and we're executing it. And then we're going to return the exports of that module. And that's kind of all there is to it. So any questions on that? That's how Webpack works. Yeah, so it's actually pretty simple. It's just going ahead and it's just setting up this essentially like basic cache here that will just go through and require things. You could sit down and you could write this. Aside from like the only tricky part of this is writing like the actual like compiler that's going to look at your stringified source code and like swap things out. That's like the hard part. This is easy. This is something that you may have perhaps written yourself already.
Is the R objects, is that the object we came up with in the first step?
Which object?
Sorry, our modules.
Bottom. Oh, down. Yeah, this is our, yeah. So in this next slide here, actually, let's expand it. So you can see here's our modules again right down here. So here's just like the full view of both of those sets of code in the same place. Is we've got our modules object just being passed in here to the iffy. You can see, remember, these are the IDs, just the file names. And we can see that we're just going ahead and, here's our function definitions, and here's where we invoke them. Cool. So it's actually, so like Webpack, of course, obviously like is much more complicated than this once you get into all the different things that it can do. But this is the main backbone of the way that it works. It's just a combination of like the compiler level that goes through and like does stuff to your stringified code. But the way that its execution is just like you would expect if you were going to put together your own common JS system. Cool. Yeah, and it's not like totally necessary to like understand like all the like the underpinnings and the way that like Webpack itself specifically works. But I just wanted to go over just to make a point of like how like not scary it is, just at a conceptual level, just to make it a little bit more approachable. Because usually where sort of like the terror comes in with Webpack is in its configuration, like in like your Webpack config. But that's actually like not that bad either. So let's go ahead and let's take a look at these core concepts and like break them down and just spend like a moment to memorize kind of like where they are, because there's actually not that many things. So we know that the core concepts, and these are all things that we've probably like written in like a very rote manner up until now. So let's just break them down one by one, talk about them, and then I think they'll stick a little bit easier. We know that the core concepts, the core fields of our Webpack config are our entry, our output, our loaders, and our plugins. So here's what that looks like. Here's our example. This could be our Webpack config right here. So we know that the first thing that we're always going to give it is our entry. That is, where is Webpack going to start? What is that entry point that it's going to set in that module system that we just said? And in that example, it was foo.js. In this example, it's a /source/index.js. This is just telling Webpack where to start. Because we know that once we start, that module is then going to pull in other modules and like so on and so forth until it eventually gets everything. This is where Webpack starts to draw up that dependency tree so that it can keep track of things. And as we're going to see, we can have more than one entry. You may have already seen like how entry can be an array, can be a pipeline of entry points. And it can also be an object with a lot of different entry points so that Webpack can go into each of them and then spit out separate bundles. And speaking of spitting stuff out, we know that there's also output, which is where to put the stuff that Webpack makes. Where does it put those bundles? So typically we would want to say, for example, it takes two parameters here, a path and a file name. The path just needs to be an absolute path, so we would normally just say path.resolve. And here I'm just putting it into a folder called dist, just because that's by default, that's sort of the convention that Webpack uses. And the file name is just going to be bundle.js. Cool. So that's all pretty simple. So let's talk. So loaders and plugins is where things start to get like a little bit hairy.
Wait, can I ask, so if you were putting it into multiple bundles, would you do it here and like have an array of file names then?
That's a good question. What we're going to find actually is there's a nice little syntax that you can use in the file name value itself that will kind of like wildcard values in based on what you call them in their entry. Let's do a quick example actually, because I think it's worth looking at. I think I have maybe a more simple example right here. Let me see what I've got. So here I've got a bar.js and a foo.js, the same ones that we've had from before. And let me look at my Webpack config. Yeah, okay, cool. So I can see here I've got my entry, which right now it doesn't match up with this at all. But let's go ahead and let's say like I want a bundle for foo.js and for bar.js. So I'm going to modify these slightly. I'm going to make it so that bar just exports bar and foo const foo equals console log foo, and like export default foo. There's like, I know these aren't really even like using any other modules, but like let's say that they had other dependencies separate from each other and we wanted to just build out a bundle for each of these. What I would do here is I would make entry an object. And let's say I'm going to call this first one, like foo. I'm gonna give it a slightly different name. I'm gonna call it foo app, where the entry point is gonna be foo. And I'm gonna have bar app, which is gonna be bar. And does need to be JS maybe. Yeah, let's make it JS. So then for the output here, it's like instead of sort of like hard coding these names, what you can do is you can put some brackets here. Say a name, just sort of like a little bit of a magic word. .bundle.js is what I'm going to call it. So what that's going to do is it's going to take each of these entry points, foo app and bar app, and it's going to spit them out into a foo app.bundle.js and a bar app.bundle.js. So let me go ahead and let me clean up whatever I've got here in my dist currently. Let me see what I got as a. Just gonna go ahead and run webpack. And can't find module. Oops, I need to npm install. Let me check my. Okay, my node version is good. So install. Let's run webpack. No, oops. What am I doing here? I think that's actually that's a reference error, isn't it? Let's get rid of this. Let's get rid of this because we don't need it at the moment. We just want to. Let's get rid of this too. We don't really need that either. Try one more time. Okay, cool. Yeah, so check it out. Like we can see that we've got our output here. The output that got emitted was we have a bar app.bundle.js, which is 615 bytes, and a foo app.bundle.js. And if we go and we check out our output, here we can see there's bar app and there's foo app. So we got multiple bundles now. Not really getting a lot of them like in a practical sense, but that's essentially how we, if we had like just multiple bundles that we wanted, this is the basic way that we'll do it.
How does it do that?
Well,
it just like
it
maps over the entries.
Yeah, it just maps over the entries.
Yeah.
Parses out this special syntax here.
Mm-hmm.
This is just specific to Webpack here. This is Webpack's domain-specific language, and it will say like, okay, this is the foo app entry, so I'm going to make a foo app.bundle.js based on this entry point, and I'm going to do the same thing for bar app. Just instead of doing it once, it does it for as many times as we want, really.
Why would you want multiple bundles? Like, I assume they would be totally separate in terms of their contents. Why would that be?
The reason you'll want to do that is if you, and this technique is called code splitting. And the very good reason that we're going to talk about later that you would want to do that is if you want to lazy load modules. So that is, instead of serving an enormous bundle down to the client at once, you just send what they need right then. And then when requests come in for the rest of those modules, then you can serve them up.
So it's kind of like performance?
Yeah, it's helpful if you want like performance, faster load speeds, and easier on memory too.
Do you need your server set up specifically to accommodate this? Fetch certain modules?
No, because what Webpack will do is it will kind of like under the hood allow it so that Webpack will do the hooking up. What you need to do is you need to make sure that in your that you're able to statically serve those files, which as long as you're serving stuff from dist, should be fine. Because essentially it'll just be an XML, an AJAX request for that script, and then Webpack will take care of sort of hooking it into everything and executing it. We'll look at that a little bit later. Cool. So that's entry, that's output. So loaders are specifying how to transform your code. So that's what they're about. And the way that they get set up is we have this key called module, which just has a rules array on it. Perhaps it's maybe a little bit unfortunate that it has to be structured this way, but you can just think of it as module.rules. Those are your loaders. And essentially it's setting up a pipeline of like a pipeline of transformations on your code. So this is where things like Babel come in. This is where things like the style loader, stuff like that. And they're all just going to be these objects, which at a bare minimum need to have a test and a use, where the test is just a regular expression saying like what kind of files should run through this particular piece of middleware, and a use, which is just telling you which loader to use. So you can just have as many of these in this array as you want. So loaders are all about transforming your code, and plugins are about everything else, sort of just like other stuff. Stuff for, like minifying code, stuff for making, like Webpack faster, just like kind of like anything that's not strictly about, like doing like a major transformation is going to be sort of like in plugins, kind of like the catch-all for everything else. Like an example, a very useful one is this HTML Webpack plugin, which what that does is it will automatically create an index HTML for you and plug script tags for all of the various bundles that you've created into it. And you can give it like lots of other configurations to like add certain meta fields and stuff like that. But this is like an example. This is sort of an example of like what a plugin does. Is it gives you sort of like a little bit of a couple like extra powers. So in this case, it's like, hey, rather than having your own index HTML and having to remember like the bundle names and everything and to put all that there, Webpack will create one for you. Pretty cool. Yes.
The rules use. What does that refer to? Like
1 second. I need to.
Loader, I think,
So my meeting is going to end in 10 minutes, so I need to. I think I'm probably going to just start kill it and start it again. Let me go back for a moment. Okay. By use.
Yeah.
Yep.
Is that the name of the module?
That's the name of the loader that you want to use. So it's saying that like, okay, like Webpack, when you get to a file that ends with .js, run it through the Babel loader. But say for example, like another common loader would be like the style loader, which is used for, like in conjunction with CSS and like SCSS and other things like that. You don't want to run a JavaScript file through your style loader. So you would say like test for / like CSS, like run like files that look like this through that particular loader. Or like a JSON loader. You don't want to put JS files through a JSON loader. You want to.
I guess maybe my question then is really how do we access that loader to begin with? Like, do we by installing Babel, the Babel loader package? Now I have access to that. Yeah,
by installing it. You need to npm install it, and then just like Webpack will just look it up in your node modules directory. Cool. So let's take a 0-minute break while I stop the share real quick. I'm going to stop the. Sorry. Okay. All right. Sorry. There we go. Beginning again. Any other questions on these 4 basic concepts? Cool. All right. So let's talk about the difference between, or rather, this thing that got introduced with Webpack version 4, which is mode. So with Webpack version 4, you get the option to specify development or production mode, which actually simplifies a whole lot of cruft from previous. Oh dear. Okay, sorry. That was my the recording from the previous one being done, which simplifies a lot of cruft from the previous versions of Webpack. And it does make your life a whole lot easier, because to be ready for to make a production build, something that is like nice and efficient for production, actually requires very little effort on your part anymore. It used to require a lot more, and now it doesn't. Let's talk about what these are. So with development, so when your mode is development, this means that you will have a global variable in to all of your modules. Process.env.node.env, and it's going to be a string development, the same way that it would be in Node. And this is really cool, because then what Webpack will do is, when it is compiling your code, is even though you don't have anything, like you don't actually have anything on your scope called process.env.node.env, it will find that pattern and it will just replace it with the string development. when it compiles at compile time. That's pretty cool. And this can be helpful because it can allow you to just have certain stuff in your client-side JavaScript that only happens in development and certain stuff that only happens in production. That's pretty cool. And it also just enables by default a few plugins that make development easier. They're not super interesting to go into and mostly related to hot module replacement, which we'll talk about in a little bit. So then production, on the other hand, it does the same thing to Node env, except it makes it production. Again, pretty cool. And there's also a plugin called the webpack define plugin that you can use to make any arbitrary identifier, like process.env.nodeenv or any other thing, and you can teach webpack to just replace that pattern with a hard-coded string, anywhere in your app. That's really cool. But what a production mode does is it enables several other plugins by default that are mostly beneficial for production. Most notably the Uglify JS plugin, which is going to minify and uglify your JS bundle, which is going to substantially reduce the size. And I think on the roadmap for future versions of Webpack, they're going to also support things like minifying your CSS out of the box. It doesn't do that yet, though I think Parcel does, though, to give a plug for Parcel, if I'm not mistaken or remembering incorrectly. So right now, if you want to minimize your bundled CSS as well, I think you just need to use another plugin. Cool. So now we know we can have a development mode and a production mode. So now we might think okay, what if we want to have multiple Webpack configs, one for production, one for development? Doesn't that mean that I'm going to have to not be dry? I'm going to have to duplicate a lot of code between the two? The answer, it does not. That's why we're talking about this section. Because there's another useful utility called Webpack merge that you can use to stay dry when you're defining multiple configurations between development and production. So here's say for example, here is I've called it webpack.common.js. This is the configuration that I want all the time, regardless of whether I'm in development or production. I've got an entry point, I've got an output, and I've got a module.rules, that is my loaders. I don't have any plugins, that's fine. So this looks good, this is all very familiar. But what we don't have here is we don't have a mode. Because what I'm going to do is I'm going to specify a different configuration file for development and for production. So I'm going to make a new file called webpack.prod production.js. And here's what that could look like, is it could have just module.exports equals mode production, and dev tool would be source map. This is a source map option that's recommended for production. So what I need to do to combine these two is I will pull in this merge function from the webpack-merge package. I just npm install this. And I'll require my webpack.common.js. Require it here. And then I just invoke the merge function with common and merge in the rest of it. Kind of similar to just using object.assign. Just putting the two together. So we can do the same thing for dev. So now here over in development land, what I can do is I just pull in merge again, I get my common, and I just merge the common into this development one, which is a little bit more complicated because it's got more tooling here. Yeah, so any questions on sort of this basic workflow of kind of dividing up your packages? Yes?
Where do you specify whether you want to use the webpack prod or the webpack dev file?
And that's going to be in your package JSON,
okay,
which I think I've got coming up. Let me see if I...
Okay. Yeah, no worries.
Yeah. Cool. Because in the CLI for Webpack, you just simply give it --config to specify which configuration file you're using.
Question going back a little bit. Can you just talk about process.env variables? I don't know if I truly understand what they are.
Well, what we have here in this case is slightly different from what they are in Node. So in Node, process is going to be is a global variable in Node. It's similar to like window or document when you're working in the browser. And what env represents in Node is it represents your operating system's environment variables. So say for example, you've got an environment variable called node env, and you can set it equal to production, you can set it equal to development, you can set it equal to Kodi if you want, and you can have a lot of other environment variables as well. And there are many that are set in in a Unix-like system, whether it's Mac OS or Linux, that are set just sort of by default. Things like your user, your the output of your your terminal's command prompt, stuff like that. Those are all environment variables, and they're all accessible from a node process on process.env in any of your modules, and that's pretty handy. For Webpack, though, what Webpack is saying here is that in your client-side JavaScript, which normally has no idea what process is because it's it's being executed on the context of a browser. It knows what window and document are, but things like process and global, those are alien to it. What it's saying here is that I'm going to take this convention from Node of having something called process.env.node.env, and I'm just going to allow you to use it in your source code. And then when Webpack compiles it, it'll replace process.env.node.env, which would normally be a big nasty reference error. It'll replace it with the string development or the string production. We'll just go ahead and just before before that JavaScript is executed. We could use the define plugin or use some other means of telling the difference between production or development. But by default, Webpack's behavior is hey, use that same convention that you have from Node.js. Just because that's what you're probably familiar with. There's no magic or specificity to it other than human convention. Cool. So, is there a question from? Okay, no. Yeah. Okay. Cool. So what we're going to talk about next is kind of what all the stuff that I've bolded here is about. And this has to do with a hot module replacement. Cool. Commonly abbreviated HMR. So this is a development technique. This is just something that we use in our development environments to help speed up our workflow for updating our modules at runtime without refreshing the page. And this is kind of nice because we know that a nice thing to have is live reload. When we change something, our browser automatically refreshes. That's cool. But the next step in coolness is you don't even have to refresh. You just go ahead and somehow magically your code knows what to do. It replaces the module and executes again. It can really speed up development, but kind of the sad news is that it's not it's not quite the magical level yet. Because to implement hot module reloading, you not only need to have something like a dev server that is going to serve bundles back and forth to your source, to your application's runtime, but you do actually need to modify your source code so that you can so that your source code knows so that your code knows how to behave when a module is replaced. So that's the reason I very rarely use it, with the exception of CSS. Because if you're using the style loader with Webpack, then it works automatically. That actually does, because CSS is easier to hot module replace than imperative JavaScript code. And but the right way that this is possible is if you're using Webpack's dev server. So here's what that looks like, is we're going to install Webpack dev server, which is by default what Webpack dev server does is it will build all your files the same way using Webpack. It'll compile them all and it will just store them in memory. It won't write them to the disk or put them in your disk directory. So it'll just have them in memory and then start a small development server. That will serve up these static files whenever you visit localhost. I think 8080 is the default in the browser.
Is that what Create React App does?
That is what Create React App uses, yeah, if I'm not mistaken. So here's how we configure it, is we can add this dev server to our development Webpack config. We can say content base, that is where are our bundles and our index HTML and everything. And that's all in /dist. And if we want hot module replacement, then we need to say like hot true, just as like an on switch for it. And we just need these two plugins, named modules plugin and hot module replacement plugin. Named modules plugin, you don't really need to worry about. That's sort of like mostly just used by, like by Webpack. Like it's like allowed. It makes it so that you can like see the modules names when they're being replaced. But the hot module replacement plugin is like more like turning it on. So let's go and let's visit our package.json. So here you can see like I've got two builds here. I've got building for development and building for production. And what they do is they run Webpack with the -- config, that is the config that it's using, either being the dev.js or the production.js. And for like our production start, it's just the regular start, that just runs, say, like, for example, like our server.js. But for dev now, we're going to use this development server. So the way that I've configured this here is we're running actually Webpack dev server rather than Webpack. -- open means when you start it, it will automatically open a new tab in your open browser. That's convenient. Not required, but convenient. And -- config Webpack dev.js. And by doing this will run all the same stuff that Webpack does, only you'll also be using the dev server, and it will start things up, like serving things right away. And if you're using the style loader, then your CSS will hot reload. And if you want to go ahead and start to actually do like implementing like hot module reloading with JavaScript, you can do that too, but it is harder. Yes?
So with this script, do we no longer need the build dev script? Is that sort of obsolete at this point?
With this, the build dev script is more or less obsolete, with the exception that like if we wanted to do a development build and then serve it up from our regular server.
Okay.
The production build is necessary though.
So could you go over again what happens? Like the modules go into memory, and then what?
Yeah, and then the dev server is going to start to serve them on some port. So let's go ahead and let's go and look at my example real quick.
Oh, as in they are not bundled. They're just getting all served.
They're bundled, but rather than running the bundle to disk, which takes more time, it just keeps them in memory. This is why when you use Webpack dev server, if you go and look inside your dist directory, you're not going to see anything there. It's because it's not doing the extra work of making a file, just to save time, because you're developing. And time is money. Yeah, so like here, like say like I've got, let's just run actually Webpack dev server here. Well, let's look at what this example has real quick. Is I've got like a dist directory that has some stuff that we're going to be talking about. But my package.json has here is it's got that same, like that same start script right here.
Hey Tom, can you share your terminal on the screen that you're sharing?
Can I share this?
I can only see your keynote.
Oh, you can. Oh, you can. You can still only see keynote.
Mm-hmm.
Oh, 1 second. That oh, 1 second. Stop. I think I must have clicked the wrong thing. Desktop 1. There we go. Is that better?
Perfect.
Great. Sorry about that. Cool. Yeah, so I can see here, like I got Webpack dev server. So let me go ahead and I'm going to just empty out my dist directory really quick. Cool, so that's empty right now. If I npm run start dev, this is going to do a couple things. I can see like here on like localhost 8080, it's just going to go ahead and it's just going to build all of my assets, which including my index HTML because I'm using that HTML plugin. and it's going to give us it's going to give me my app here. So I got like Cody and home and stuff like that. But if I go and I explore, say, the dist directory right here, I can see it's still empty. That's all that we mean by it just doesn't do the extra busy work of writing to disk. Cool. So now, like, a problem though is because you're using this dev server rather than your real server, is that kind of like how do you do like AJAX to your API or anything like that? Like if you've got a real server that's serving stuff via your API, then how do your dev server has no idea that your regular server exists. So here's the way. So the way that you would fix this for development is you just set this additional option to proxy any requests that start with a certain pattern to your regular server. So you just go ahead and you'll start your regular server, just like either in a separate tab, or you can actually have you can set an after hook here as well if you want to just go ahead and start your server for you, just like programmatically. But here we're saying like, okay, like we're going to have our dev server running on port 8080 and our regular server running on port 8000, let's say. So if we get a request to our dev server that starts with /API, then we'll proxy it to localhost 8080. Likewise, for like any static assets, I'm going to put those that like aren't in the bundle. Those can also go to 8000 as well. So this can make for a really convenient dev workflow when you have more than just a client app.
You have to do that with Create React App. I ran into that at one point. Yeah,
because what Create React App has no idea like what kind of server you're going to do. So it uses Webpack Dev Server just like this. So once you actually build a real server, you'll need to proxy those requests. Cool. But yeah, so just sort of like out of the box though, like out of the box with this, you do get hop module replacement for your CSS though. Because like here, like let's see, like you can see I've just got this after hook here, which is just starting my server. I need to, let me see where if I go, oh, it's in my comment actually. Sorry. So here I can see I got style loader and CSS loader. So in say, for example, my source code over here, I've got my index.js and I've got my index CSS. So let's say, let me go ahead and we're still running? We're still running. So here I got like my page right here. Let me go ahead and just put it on the same things. All right, okay, I'm recording again. Hopefully that all works out. Yeah, okay, so I don't know if you saw, like I changed the color to Burleywood and it just changed without needing a refresh. I can change it back to 333 and no refresh involved, it just does it. So as long as you're using style loader and Webpack Dev Server, you get that out of the box. That's pretty nice. For actually like changing the JavaScript without reloading, that requires more work. You need to actually code that into your modules. I don't do it so much. If you're using React, then there is actually a higher order component that you can use that will sort of like bake it into your components. It's I think like React Hot Loader or something. It's like by Dan Abramov. It's part of the ecosystem. But it just involves kind of like wrapping all of your like the components that you want to hot reload into this other higher order component. So it's up to you. I like to keep things minimal, so I usually just settle for the CSS. Cool. So let's wrap up talking about code splitting. Cool. So the idea here is that rather than bundling up all of your client-side JavaScript into this one bundle, we're going to break it apart into separate bundles. And then our client app can just go ahead and lazy load our modules when it needs them. And the reason that we do this is because if you've got an application that has, say, like admin users and regular users, do your regular users really need all the JavaScript for your admin pages? They don't. So instead what we'll do is we'll take the JavaScript for those pages, for those components, let's say, and we'll put them in a separate JavaScript bundle. And then, what we'll do is we'll just, when somebody clicks on a link to go to that page, we'll use the dynamic import, which is currently a stage 3 proposal in, like in ECMAScript world. So it's on its way. It's going to be part of the official spec more than likely. We'll use this dynamic import, and kind of like Webpack will basically like take care of the rest. It will. We just need to give it the path to the module, and Webpack will automatically spit out different bundles. And whenever it encounters and what it will do with the dynamic import is when it's compiled, it will replace it with an implementation that will perform an AJAX request for that JavaScript, kind of like insert it into the Webpack runtime and execute it. Really cool. A little bit, it'll seem a little bit magic-y, but it is nice that it's easy to implement. So here's what we need to do just to get set up is for our entry, we need to have more than one entry. So what we'll do here is we'll have our main app here just be, we'll call it app, and that's our main entry point. And we'll use that domain-specific name.bundle.js. And that's all that we need to specify, actually, because everything else that we do, Webpack is just going to infer it based on the dynamic imports in our source code. When it compiles, it will find all those dynamic imports, and it will automatically create the bundles for them. It's very cool. So here's what that looks like. So I've got a React application here. So let's go ahead and let's dive a little bit into. Here I got my index.js. I import React, render. I get my app component, and I've just got a main function that creates a div, and I go ahead and I'll just render app into that div, just after appending it to the DOM. And I'm just doing this because I'm using that HTML plugin that automatically generates my my HTML for me. So I got my app over here. Cool. So here's where the magic happens. Is that I've got like a basic nav bar that links to Cody and to home, and I've got routes for each of them. And the component for them is going to be either what I'm calling async Cody or async home, which I'm creating here. And what they are is they're the result of this load component function, which is just a higher order component, which is taking in this function that uses the dynamic import for /home and /Cody. That is the /home and /Cody module that I have right here. And it's important that I'm creating them here and not sort of like exporting them from Cody or from home, because then that means that Webpack would need to read those files during compile time and include them in the bundle, which defeats the purpose. What we're saying here is that what we want is we want this function to give us the like the components that we want. So here's where our load component higher order function looks like.
So just to be clear, you're not exporting anything from home and Cody.js.
Yeah, exactly. Like very important that we don't have import anything from home or Cody. Instead, we just have these function calls that haven't been executed yet, and they won't be executed until we click on one of these links. So here's our higher order component. We're passing in the callback to fetch our component with the dynamic import. We've got we've got a state which our error is false and our component is initially null. And on component mount, we await our fetch component call. And this is going to be this callback here that uses the dynamic import. Because what Webpack has, the way that Webpack has implemented this import function is that it will make a request for the bundle that's associated with it that gets created at build time. And it will execute it and give us the default exports of that component. We do need to do this kind of like default, like as component thing here. So then what I'll do is I'll just set state with my component, and if there's an error, I'll set state with the error. Just like this is just a regular loading something component, really. So then here in my render, if I have the component, I'll get the component in error, If we've got a component, then they'll render the component. If there's an error, I'll render oh no's. Otherwise, I'll render loading. Pretty conventional. So then here's kind of like what that looks like now during build time. Let me go ahead and that's the simple example. Let me npm run build dev. Cool. So here's what we got here. As you can see, I've got app.bundle.js. And I've also got 0.bundle.js and 1.bundle.js. And I think there's probably a way I could have configured these better so that it would actually have the name like Cody.bundle.js and like a home.bundle.js, but by default, it just numbers them in whatever order it's encountered them. Okay, I think we can wrap this up in 10 minutes because it's also 1 o'clock. So I can see here, I've got 0.bundle.js and 1.bundle.js. It just made separate bundles for each of those dynamic imports that it saw in my source code. So you got those bundles there. So what's going to happen is when I run my code, we're going to get our app.bundle.js. And then when we click those links, we're going to make requests for this other JavaScript that's going to get executed on the client. So let's go ahead and I'm just going to run my server, not even the dev server. We'll just run off of my regular server on port 8000. Let's go to $8,000. Thank you. There we go. Let's go ahead and let's open up the network tab as well, just so that I can prove what I'm telling you about. So go ahead, we're going to execute. And here's what we get on our initial load is we got let me pull it up here a little. Oh dear. Go away. Yeah. I'm gonna pull it back a little bit. There we go. Okay, there we go. So cool, so we can see that we've got my automatically generated index HTML. I've got my app.bundle, and I've got, like this other thing here, which I think this has to do with the dynamic. I think this is essentially like the runtime that's going to actually do the magic stuff for getting my dynamic stuff. This is the technical terms. Yeah. Cool. So here's what's going to happen is I'll click on Cody, and it made a request for 1.bundle.js. Gave me the component, and now I just is able to render the component normally. When I go to home, I get a 0.bundle.js. Gives me that component, and then it can be rendered. And now that they're here, they're there. They're cached. I don't need to make a request for them again. If I refresh on home, that's just going to cause I get my app.bundle and I get my 0.bundle, but I don't get the 1. So this is a really nice way if you've got some a part of your app that not everybody's going to go to. You can split them up like this, and you can really decrease the amount of stuff that's going over the wire. Really easy and fun to implement. So I think that's all I got. I think that was my last slide. Yeah, that was my last slide. Cool. So got about 7 minutes left. Any questions? Yes.
How do you implement in LearnDot, since there's so much of an admin functionality behind there?
No, LearnDot is so behind the times.
Okay.
I was just talking to Griffin about tearing some stuff up and replacing some things so that we can actually take advantage of these things. Because right now, it's still a lot of it's on Angular 1, and I'm not even sure that it's possible to do this. And I think it maybe is, but yeah, no, it's gotta get its life. We'll get there.
With the dynamic imports, is there a little bit of a trade-off between sort of having an application where you have a slower initial load time and then your links are really fast to already have parsed the JavaScript?
Yeah,
versus,
exactly. It's a trade-off. It's like just because you can do it doesn't mean you want every single component that you have in your app to be like lazy loaded. Because it might be that like, okay, like the initial load is a tiny bit, like slower. But then you have all that stuff there. So if it's likely to be used, then it's a lot quicker. If it's already there, like in the browser, like in memory, it's already been executed. Versus like having to make another network request is slower. So the idea here is you're trading off between the initial load time and kind of like the initial load time and like subsequent load times. So you kind of like choose wisely. It's usually kind of like the way that I look at it is it's best to sort of like break up kind of like modules that have like kind of like different domains, like regular users and admins and things like that. Cool. Any other questions? Cool. Is Webpack less scary now? Is Webpack fun? We'll get there. It's okay. Yeah, like I said, like Webpack's also not the only game in town. There's also like Rollup and Parcel. For a while, I think sort of like but kind of like there was like this convention for a while that was like like use Parcel, use a Rollup for libraries and use a Webpack for apps, because Rollup didn't have kind of like the code splitting features that Webpack has that make it advantageous for like applications, but it was a kind of like faster at putting stuff together. But that's sort of like not the line's really blurring there, because Rollup does now have code splitting, and Parcel I'm really excited about because it tries very much to be kind of like more opinionated and more out of the box than either Webpack or Rollup, and is also very fast. So I do recommend like checking it out as well. But either way, sort of like the two big fundamental concepts that kind of like all like JavaScript module bundlers revolve around is this idea of kind of like collecting your source code, putting it into modules, and allowing features like HMR and code splitting. Like so those are all sort of like whichever like way you decide to go, or like whatever we're using in the future, those are probably those are going to be the things here that are kind of the core concepts. Cool. All right, I'm going to stop this meeting and stop the recording, and hopefully have everything put together soonish. Cool. Thanks for joining, everybody.
Thanks, Tom.